Assalamualaikum and good day to our lecturer and everyone. Today, our group consisting of Farzana, Alia, Nabil, Hanim and myself, Reen, will be presenting our project for Introduction to Business Statistics. Our topic is a statistical analysis on the registration petrol-powered cars in Malaysia, focusing on data from the year 2023 until 2025. Let's begin with the background and introduction of our study. First of all, the automotive industry is an important sector in Malaysia because it contributes significantly to the country's economy and transportation system. While alternative vehicle options exist, petrol-powered cars are still widely used and remain the dominant vehicle type in Malaysia. Therefore, this study focuses specifically on the registrations of petrol-powered cars from the year 2023 until 2025. The data for this study was collected from the Road Transport Department, or JPJ, through the official data.gov.my portal. The primary objective of this study is to analyze the pattern of petrol-powered car registrations using statistical methods such as frequency tables and calculations. Next, let's look at how we organize this data into our frequency distribution table. So, this is the frequency table constructed from our data. We group the continuous registration numbers into 5 distinct classes. For the registration range of 45,000 to 51,999, the frequency is 4. The range of 52,000 to 58,999 has a frequency of 8. The range from 59,000 to 65,999 recorded a frequency of 11. The next range, 66,000 to 72,999, shows a frequency of 12. And finally, the highest range of 73,000 to 79,999 has a frequency of just 1. Now, let's summarize the key findings from this distribution. So, this slide summarizes what the frequency distribution reveals about our data. The frequency table allows us to group our raw data into distinct class intervals so we can see the overall pattern. As mentioned, the frequency column simply shows how many data values fall within each specific interval. Our key takeaway here is that the interval of 66,000 to 72,999 has the highest frequency, which is 12. This indicates that a monthly volume within this range was the most common registration performance for petrol-powered cars in Malaysia over the 3-year period.
Hi, it's me Alia. I will explain to you about central tendency. So the first one, we have mean. The mean is calculated by summing all the values in the dataset and dividing them by the number of values. It represents the average value of the dataset. For the petrol-powered car registration data, the mean provides an overall average number of newly registered vehicles per period. For formula, we use mean. F multiply with X divide with N. Mean calculation. Product of frequency and midpoint. We multiply, we got 2,235,982. Total number of data, N, is 36. So last step, we must divide them. And we got 62,110.61. Next, we move to the next part, is median. The median is the value that lies in the center of data. The median indicates the central point of the dataset and it's useful for understanding the distribution of registration numbers, particularly in reducing the effect of exceptionally high or low registration periods. For the formula, we use this. Lower class boundary of class median is 58,999.5. Number of data, N, is 36. Position of median class, N, divide by 2, and we got 18. Cumulative frequency before median class, we got 12. Frequency of median class, we got 11. And the last one is median class size, 7,000. After that, we put all the information in this formula, and we get 62,817.68. Lastly, we have mode. The mode is the value that occurs most frequently in the dataset. In this study, the mode identified the most common or typical range of petrol-powered car registration reported by the Road Transport Department, JPJ. For the formula, we use this. Model class 66,000 minus with 72,999. Lower class boundary of model class, L mode. We need to minus with 0.5 and we got 65,999.5. For the first quartile, 12 minus with 11 and we got 1. For the second quartile, 12 minus with 1, we got 11. model class size, we got 7,000. And we put all the information in the formula and we got the answer is 66,582.33.
Next, this slide explains the range in measure of dispersion. Range is used to find the difference between the highest value and the lowest value in dataset. The formula for range is highest value minus lowest value. In this example, the highest value is 79,999.5 and the lowest value is 44,999.5. So we calculate 79,999.5 minus 44,999.5 and the answer is 35,000. Therefore, the range for this data is 35,000. Then the interquartile range or IQR. The interquartile range measures the spread of the middle 50% of the data. It is calculated by subtracting the first quarter Q1 from the third quarter Q3. First, we find Q1, which is the 9th position. The value of Q1 is 56,374.5. Then we find Q3, which is the 27th position. The value of Q3 is 68,332.83. Finally, we calculate the interquartile range using the formula Q3 minus Q1. So, 68,332.83 minus 56,374.5 gives us 11,958.33. Therefore, the interquartile range for this data is 11,958.33. This slide explains quartile division, which measures the spread of the middle 50% of the data. The formula used is QD equals Q3 minus Q1 divided by 2. Here, the first quarter Q1 is 56,374.5 and the third quarter Q3 is 68,332.83. First, we subtract Q1 from Q3, which gives 11,958.33. Then we divide the result by 2. So the quarter division is 5,979.17. This means the middle half of the data varies by about 5,979.17 from the center.
Next, I will explain the variance for this data. Variance is used to measure how spread out the registration data is from the mean or average. First, we calculate the mean, which is 62,110.61. Then we substitute the values into the variance formula. So after calculating, we get the variance value of 54,293,209.88. This shows that the registration numbers are quite spread out from the average value. Next is the standard deviation. Standard deviation is the square root of the variance. By using the variance value, we calculate the standard deviation. The standard deviation obtained is 7,368.3. This means the registration number usually differ from the mean by around 7,368 registration. A higher standard deviation indicates the data is more spread out. I will pass to Hanim for the 5.0.
For the histogram graph for the registration of petrol-powered cars shows the frequency of registration within defined intervals, known as class boundaries. Each bar represents the number of cars registered within each interval. The interval 65,999.5 until 72,999.5 has the highest frequency, 12 cars, indicating the most registrations fall within this range. For the OGIF graph shows the cumulative frequency of the registration of petrol-powered cars. The x-axis represents the upper class boundaries, while the y-axis shows the cumulative number of cars registered up to each upper boundary. The cumulative helps to determine the total number of registrations below any given value and is useful to finding median, quartiles, and percentile in the database. For the conclusion, this study analyzed petrol-powered car registration in Malaysia from 2023 to 2025. The highest registration frequency was in the class interval 66,000 to 72,999. The mean registration was 62,110.61. This assignment helped us understand the application of business statistics in real-life situation.